So what is efficiency? Efficiency is a level of output per unit of input. So how much are we getting out per the amount that we've got to put in? So let's stop and think about an example real quick. And I really like this example. Let's talk about an example using which one is going to be more efficient. Well, first and foremost, the lower the amount of inputs, the lower the amount of inputs needed to obtain the same level of output, the more efficient. So the less that we have to put in and the more we can get out, or if we're looking at the same level of output, the less we have to put in, the more efficient we are. So let's take two different types of vehicles. We take a small sedan, and we take a pickup truck. So the small sedan will actually cost about 46.4 cents per mile to drive the small sedan. Whereas this truck, on the other hand, it takes 67 cents per mile to drive the pickup truck. Now, how far are you going in both of these examples? You're going 1 mile. So we're looking at one unit of output. And how much does it cost, or how much amount of inputs, resources do we need to use to go that same level of output? So in this example, we're not pulling anything, we're not loading anything, we're not doing anything like that. We're just driving 1 mile. So both provide the exact same output, but the sedan is more efficient. And we know that the sedan is more efficient because it costs less, because we're using less money to do that. We're using less resources in order to drive the small sedan, and we can save more resources to apply them somewhere else. But it takes less resources, less cost to drive that small sedan as compared to that truck. So how does this tie into average cost? Well, average cost shows us the cost per unit of output. How much does it cost on average per unit of output? So the lower the cost, the more efficient the production process. You get the same output, but at less cost. What if your business was to, say, haul flowers, deliver flowers, and you could do that in a small sedan, or you could do that in a pickup truck, and all you're doing is just driving around town delivering these flowers? Well, which one are you going to choose? You might just choose a small sedan. In theory, you should choose a small sedan because it's more efficient, because it's a lower cost. It's a less cost, but the exact same output. So now that we know that the average cost basically shows a cost per unit of output, and that a cost per unit of output basically helps us measure efficiency, at the lower the cost per unit of output, or the lower the average cost, or the average variable cost, the average total cost, the average fixed cost, the more efficient this is. Let's actually dive into how these three different curves look in terms of efficiency. So first and foremost, as output increases, you are continuously becoming more efficient with your fixed costs. Remember that your average fixed cost continuously decreases. If we look down here at this graph, your blue line is your average fixed cost, and that blue line just continuously keeps going down. Well, why is that? It's because you have this fixed number, this solid number, the one number that doesn't change for your fixed cost. And as you produce more, as your output increases, you're actually doing what's known as spreading the overhead. You take that fixed cost, that standard fixed cost, and spread it out over more units of output, and you're going to spread that overhead out. So basically what you're doing is you're taking that common cost of, say, $100, and you're splitting it up over more units of output to where the unit, or the cost per output of fixed cost, continuously decreases. So what's happening? Your average fixed cost, your fixed costs are continuously increasing in efficiency as we spread that overhead out, as we increase our output. Because your fixed costs don't increase, we're actually spreading that overhead out. Now, what about average variable cost? So as output increases, you become more efficient of the variable cost, and then it hits a point. And after it hits that point, then you start to become less efficient. And that has to do with that average physical product curve. Remember that average physical product curve measures the level of output per unit of input. And in the beginning, our output per input was increasing, which means we were actually becoming more efficient. We could produce more with the same amount of inputs, and then it hits that peak, and then it begins to fall off. It hits that peak, and then the output per unit of input begins to actually lessen. And that's what's going on here with this average variable cost curve, is that it's increasing in efficiency. Our cost per unit of output is decreasing. It's continuously decreasing. And then it hits that point right there at 8.1 units of output. And then it begins to increase. And it's increasing because that we're losing that efficiency, that we're not able to produce as many outputs with the same level of inputs. So, average variable cost, it actually decreases up until a point and then begins to increase. And that has to do with that law of diminishing marginal product that we talked about earlier in this chapter. With this law of diminishing marginal product also plays into that. And remember, the law of diminishing marginal product says that as you use more of any good, of any certain input, the rate of increase will eventually, remember that law of diminishing marginal product says that as you use more of any one input, as you continuously increase the level of any one specific input, the level of output off of each additional unit will eventually begin to decrease. Remember that marginal product will eventually begin to decrease, and that rate of increase is going to decrease due to that law of diminishing marginal product right here. So, whenever it comes to average variable cost, we actually are becoming more efficient, hit a point, and then we start to lose efficiency. Now, let's look at average total cost. So we know that average total cost is actually a combination of average variable cost and average fixed cost. So, average fixed cost is continuously increasing in efficiency, whereas average variable cost in the beginning will increase in efficiency. So at first, both average variable cost and average fixed cost are becoming more efficient. So, remember that stage one of production that we talked about, and that stage one of production was actually dealing with ends at the peak of the average variable cost curve. Well, that average variable cost, at the peak of the average physical product, and we now know that the minimum point of the average variable cost and the maximum point of the average physical product curve are at the same point. But this is why you don't produce in stage one. Because think about it, ladies and gentlemen. In stage one, which technically ends right here, it's going to end right there if we were to transpose that stage one and put it on this graph. And in stage one, by increasing production, by increasing output, you're becoming more efficient with average fixed cost and average variable cost. It's continuously costing you less per unit to produce this product. So why would you not want to capture on that? Why would you want to pay more per unit to produce it? So we never produce in this first area, or if you're producing in this first area, you're going to want to move out of it very quickly. Because by increasing production, you're gaining efficiency in both the average variable cost and the average fixed cost. Then you hit this point, you hit this trough, this minimum point of the average variable cost. After that, average fixed cost is still increasing in efficiency, but average variable cost begins to decrease in efficiency. And that line is beginning to go up. So what's going on there? What's happening to average total cost? Average total cost, well, is increasing in efficiency all the way to about this point right here. So the minimum point of the average total cost is just going to be a little bit further at a little higher output than the average variable cost. And the reason why is there's actually a trade-off between efficiencies for a little while. Or we're starting to see a trade-off of efficiencies between the average variable cost and the average fixed cost. Because the average variable cost is losing efficiency at this point, and average fixed cost is gaining efficiency, we actually have a little bit of a trade-off there. So essentially, just to recap, efficiency, the more or the less it costs us per unit of output, the more efficient we are. Output, or average fixed cost, continuously is going to increase in efficiency. Average variable cost is going to increase and then decrease in efficiency. Average total cost is going to increase but decrease in efficiency. But after we get past this minimum point of the average variable cost curve, then we actually have a trade-off of efficiencies between average fixed and average variable, and that's what accounts for our average total cost.